All right, chemistry class. In this episode of nomenclature, this will be part 4. You should be around composition notebook page 25 and 26, but if you've got room on page 24, you can just add this to it. So today what we're going to talk about is naming and writing compounds with what's known as polyions. And again, we've talked about this in previous videos. A polyion, or sometimes called a polyatomic ion, is a group of atoms that are joined together that has a charge. Now, in class, what I'm going to do is I'm going to give you a chart that's going to have a list of the polyatomic ions. And you'll need to start learning these polyatomic ions, but for now you can use this chart. And so you don't necessarily have to have them memorized right now, but you need to start learning these as we go along in class so that it'll make your naming a lot easier. Now, the great thing about this is that we use the same rules that we use for other polyatomic ions. So here's just a little thing right here. I asked the cat sitting next to me if he had any sodium hypobromide, and he said, "Nah, bro." Yeah, that's the corny chemistry joke of the day, but NaBrO is an example of a compound that has a polyatomic ion in it. So I thought I'd throw that in there. All right, here's your rules. Again, these are the same rules that you had for naming binary ionic compounds. And so they're really the same thing. You can pause the videos, you can jot these down, or you can just simply say use the same rules for binary ionic compounds. So here again, you're going to, first of all, name the cation. Cation is their positive ion. It's always written first in the name of the compound, so it makes it easy. Just name it. Number 2, you're going to use Roman numerals to indicate the charge. Again, that's if the metal is a transition element. Where are the transition elements? They're in the middle of the periodic table. That's groups 3 through 12. So if it's located there, you'll want to indicate the charge there. And then third, you're going to name the anion, the negative portion of that. And if it's a polyatomic ion, you don't change the ending. You just name whatever that ending is. It might be chlorate, it might be chloride, it might be hypochlorite, something like that. Not chloride, but chlorite is what it should have said. All right, and then also your rules for writing formulas. Again, these are the same rules that we wrote down for a regular binary compound, so you can refer back to those, or if you want to, you can jot these down again in this section here. So again, what we're going to do is going to write cations alone with the charge. That is the symbol, and put the charge with it. We're going to write the anion alone with the charge. If it's a polyion, we're going to write the entire polyion and the charge that goes with that entire thing. And then number 3, determine the ratio of cations to anions so that the charge adds up to 0. Remember, the sum of the charges always need to be 0. And then fourth, we're going to simply use parentheses for any polyions. All right, so let's shift over a little bit here and go to our notebook paper, and we're going to write down some examples of these. And again, it's the same rules, so just follow along with me as we have this. Have your periodic table handy, and also have that sheet of polyions that you were given in chemistry class. All right, so here are some examples of what we're talking about when we deal with naming and writing formulas that involve polyatomic ions. So let's go from the formula to the name. That's what we're first of all going to do. Formula, and we're going to name them, okay? Formula to name. So our first example, we have Ba and then parentheses NO3 with a 2 on the outside of the parentheses. And so these parentheses let you know this is a polyatomic ion. Anytime you see parentheses in a formula, that automatically tells you you're dealing with a polyion. All right, so we named the cation first. Ba is barium. You have your periodic table, so in case you didn't remember what the name of Ba was, you just look it up on your periodic table. We don't need to worry about anything else at this point because barium is not a transition metal. Then we look at the polyion. All right, NO3, if you look on your table of polyions, NO3 has a specific name. That name is nitrate. So we simply write down nitrate. ATE ending on it. We don't change anything. That is the name, barium nitrate. All right, so that's pretty straightforward. So let's take a look at this one. Al2 and then CO3 inside the parentheses with a 2 on the outside of the parentheses. Excuse me, a 3 on the outside of the parentheses. Al2, CO3, and a 3 on the outside of the parentheses. All right, so aluminum. Al is aluminum. So we're simply going to write down aluminum. Now, do we need a Roman numeral with aluminum? Do we? Well, if you're not sure, look it up on the periodic table. Aluminum is in group 13. So no, it is a metal, but it's not a transition metal. So we do not need to write Roman numerals with aluminum. And then we simply look at the anion, the polyanion here is what we call it. And it is CO3. We look at our table of polyions, and the name of that is carbonate. ATE ending on this one. Now, not all the polyions have an AT ending on it, but many of them do. All right, let's take a look at another example. Let's look at CR and look at ClO3 with a 2 on the outside of the parentheses. All right, so CR, well, that's chromium. Again, look it up if you're not sure. And then we ask ourselves, is chromium a transition element? Is it found in the middle? Well, consult your periodic table. Chromium is located here. It's in group 6. So since it's contained within the transition metals, we have to do something a little bit different with chromium. What do we need to do? Well, we need to write a Roman numeral to tell us the charge of chromium. So leave you a little space right here, okay? Just leave a little space right here. We'll come back to it. You could put parentheses around it. It's fine too. And we're going to leave a little space here. Then we see ClO3. It's in parentheses, so we know it's a polyatomic ion or polyion. And the name of that one, we look it up on our little sheet, is chlorate. So again, we have an ATE ending on it, okay? Had it been ClO2, it'd been chlorite. And you just look that up on your chart. Now what we need to do is figure out what is going to be the charge. So we do it just like we did binary compounds. We're going to write down the symbol CR. We're trying to figure out what is going to be the charge, what goes beside the CR. We write down ClO3 because that's chlorate, and we write down what its charge is. Again, look at your table of polyions. And chlorates has a -1 charge. Well, how many chlorates do we have? We have 2 of them, right? So when we look at this, the -1 gives you a 2 negative. And remember, that needs to add up so that the whole thing equals what? It has to equal 0. So since we have only 1 chromium, what must be the charge that goes here? Well, it has to be a 2 plus. So that means chromium is a 2 plus. So what do? We write that as a Roman numeral. Since it's 2 plus, we write Roman numeral 2. And we would simply read this as chromium chlorate. Now, you can leave the parentheses off if you want to. In the other video with these, I put parentheses on them. Sometimes you see it without the parentheses as well. So, it's up to you. You can put parentheses on it or leave them off. And either way is fine with me on that one. All right, the next one that we're going to do is Cu2SO4. Cu2SO4. Okay. And Cu is what element? Well, it's copper. Again, if you're not sure, look it up on your periodic table. Is copper a transition element? Well, find it, locate it. It's right here. So yes, it is in the middle, group 11. So leave a little space right here. SO4. Now you look at that and you say, well, that's not binary. Remember, binary means you have 2. This compound has 1, 2, 3 elements. So you ought to think to yourself, well, this must involve a polyion. It doesn't have parentheses around it. We'll talk about why when we get to writing formulas. It doesn't have to have parentheses around it. But you see this group together and you ought to recognize it. Look it up on your polyion sheet and you'll find the name of it. And this one, again, leave a space, and it is sulfate. ATE ending on that one as well. Now what we have to do is we have to figure out what's going to be the charge on our copper. So we go back, we write Cu, and we write another Cu, and we're going to try to figure out what's going to be the charge on each copper. Sulfate is a polyion, so it's SO4. Remember, it's grouped together. And we don't break up the sulfur and the oxygen. It's grouped up together. We look on our table that I gave you in class, and we find that sulfate is a 2 negative charge. So we want to take a look at this. We've got to figure out, okay, what plus 2 negative equals up to 0? All right, well, it has to be a 2 plus. No. Does that mean that each copper is 2 plus? No. Remember, these have to add up to 2 plus. So what must each copper be? Well, they have to be 1 plus because 1 plus and 1 plus equals 2 plus. And that will cancel each other out and equal 0. So copper would be called copper Roman numeral 1. Or we just simply read it as copper 1. We don't write copper 2 because each copper has a 1 plus charge. So therefore, this is simply known as copper 1 sulfate. Okay? Now let's take a look at another one that looks a lot like it. The thing about copper is that copper can take on more than one charge. Some coppers have a 1 plus charge, but others don't. So here's another formula that involves copper and sulfate. So we write down copper, just like we did in the first one, leave a little space because copper is a transition element. We write down sulfate just like we did in the example above. But now we've got to figure out what's going to be the charge. Well, we have Cu. We've got to say what's going to be the charge here. The only way to figure that out is look at the anion. Sulfate, again, has a 2 negative charge on it. So we have to have 2 negative plus something equals up to 0. And so we obviously know that that's a 2 plus. Since there's only one copper here, that copper must have a 2 plus charge. So therefore, we're going to write copper 2, Roman number 2, that is, and we read it as just copper sulfate. All right. Now let's take a look at another one. All right. NH4Br. NH4Br. Now again, this is something that just comes with practice. You will need to recognize this. NH4 is a polyion. You say, well, how do I know that? Well, you look at this NHBr and you have 3 atoms here. So you know it has to involve a polyion. You look at this, you say, well, that's just regular bromine, so it's going to be bromide. So this must be the polyion. Look at your chart of polyions, and you'll see this one. It's a positive charged polyion, and it is called ammonium. All right, ammonium with an M. All right, now obviously that's not a transition element, and so then we just simply look at the anion, and this one is bromide. Remember, again, the ending is, if it's just a regular anion, the ending's always changed to what? IDE. So we're done with that one. All right, let's see if we can put another one right here on this page. I think we can fit this one in here. Let's go Fe2 and then CO3 in parentheses with a 3 on the outside. All right, so Fe is iron. Iron is a transition metal, so we leave a little space here. CO3, we've had this one before. That's a polyion. It's known as carbonate. We just write down carbonate. All right, and then I'm going to put this over here on the right so I have a little more room. We need to figure out what's going to be the Roman numeral. So we're going to write down Fe, Fe. Then we're going to write down CO3, 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 because we're shown that we have 3 CO3s, so 3 carbonates, and we have 2 irons. Now, each carbonate has what kind of charge on it? A 2 negative, 2 negative, 2 negative. We don't know what the charge on each iron is going to be. That's what we're trying to figure out. So we have to look at the sum of your carbonates. So that gives you a 6 negative. So that has to equal up to 0. So in order for that to equal up to 0, we need 6 positives over here. Since we need a total of 6 positives, that means that each iron is going to be what charged? That's correct. That should be 3 positive charge, because 3 positive plus 3 positive is 6 positive. So that's 6 positives broken up between those 2 irons. You say, well, how do I know I had 2 irons? Well, my formula was given to me, and I show you here you have 2 irons. So since the charge of the iron is a plus 3, then the Roman numeral becomes Roman numeral 3. So it's iron 3 carbonate. All right, the next example that we're going to take a look at is PbSO3. PbSO3, that should be contained in parentheses with a 2 on the outside. Now, lead, Pb is lead, Lead, and then SO3, you'll look that up on your polyion sheet, and that's called sulfite. So we don't change the ending, we just write it down. Now, lead is one of these that has a different little thing about it. And so if you look on your periodic table, where is lead? Well, lead's located right here. It's in group 14. It's not a transition element, but lead is one that sometimes gets a different charge. Some leads are 2 plus and some leads are 4 plus. So you might want to write this down on your periodic table the same way that I just did here. And that's the same thing with tin as well. Sometimes tin is 2 plus and sometimes it is 4 plus. It just depends. And so write that down, and then we'll treat those just like we would a transition element. So you go back to your example, we need a little space here. And so let's figure out what the charge is going to be for this one here. And so we're going to have Pb, there's only one of those in the formula. Then we have SO3, SO3, and we look up the charge on sulfite, and then we see it's a 2 negative and a 2 negative. So again, what's going to be the charge here? Well, we add up our 2 negatives, gives us 4 negative. And so that has to say, well, what plus 4 negative gives me 0? What's going to go there? Well, obviously, this has got to be a 4 plus. Since there's only one lead takes on a 4 plus charge. So since this one is 4 plus, I'll write it here. Okay. Then we need to have the Roman numeral 4. So the Roman numeral 4 is IV. And so that becomes lead 4 sulfide. All right, let's do one more on this one. We have CuOH2. And so we do this one the same way. We have copper. Remember, it's a transition element, so we leave a blank. OH, it's in parentheses, so it makes it clear. It is known as hydroxide. Okay, now it has an IDE ending on it, but it is a polyion. That's just the name of it. So now we need to figure out the charge. So we have one Cu, we have an OH and another OH. OH is 1 negative, 1 negative. So we add that up, gives you a 2 negative. So what plus 2 negative gives you 0? And obviously that's got to be a 2 plus. 2 plus is what I'm trying to write here. So 2 plus and 2 negative equals 0. And so that means copper needs to be a 2 plus charge here. So therefore we write copper, Roman numeral 2, hydroxide. All right, we'll talk more about this in class. And if you're having any problems, just come with your questions and we'll do plenty of practice problems. See you next time.